Hi, I'm Abby. I'm with LDV Capital. We invest in deep technical people building visual technology businesses. We thrive on collaborating with teams that leverage computer vision, machine learning, and artificial intelligence in order to analyze visual data. Thanks so much for tuning into our series, Women Leading Visual Tech. The purpose of our series is to highlight some of the top ladies whose work in visual technologies are revolutionizing business and society. In this interview, I had the pleasure of speaking with Dr. Lourdes Agapito. She is a professor of 3D vision at the Department of Computer Science at University College London. There, she leads a research group with a focus on 3D dynamic scene understanding from video. Dr. Agapito received her PhD in computer science from the Universidad Complutense de Madrid in Spain. Dr. Agapito was granted the Marie Curie Postdoctoral Research Fellowship. In 2017, she co-founded the company Synthesia, one of our LDV portfolio companies, that generates localized and personalized videos using AI. I really hope that you enjoy this session with Dr. Agapito as much as I did in learning about her journey as a researcher, a team leader of research institution, as well as a founder of her own company. Enjoy. Well, thank you so much, Lourdes, for taking the time to chat with me today. We're so pleased to have this conversation. And I know that it's tough times with the pandemic and school sessions ending and everything else. So thank you so much.
It's a pleasure.
So, I mean, you've got so many roles that you're balancing at the moment as a professor and also a co-founder of your own startup. What does your work-life balance look like right now, especially as we're trying to manage all of this from home?
Yes, I mean, it's difficult, right? Because being a professor means that, you know, you're doing more than one job. We have teaching, we have research, management, admin. There's so many things to juggle, and then on top of that, you know, the entrepreneurship with Synthesia. So I think the key about all this is to surround yourself with a great team. That's always for me been the answer. You know, I think I try to work very closely with my PhD students, with my postdocs, have a very kind of tight-knit group that helps. You know, everybody's moving in the same direction, and then you can move a lot faster, and you can achieve a lot more if everybody is working together. And likewise with a company, right, with Synthesia. So we have a team where everybody is able to focus on whatever they do the best, and not have to do many other different things. And I think
divide and conquer. We talk about it all the time. How can we divide and conquer?
And each person, you know, is unique, and they're good at something, and so for them to be able to flourish on that, I think is a great thing. I mean, having said that, you know, our daily routine is pretty crazy. It's pretty crazy, and yes, these days, you know, running everything from home. If anything, I have to admit that for some things it's actually been fantastic.
Oh, that's great.
Commuting means that, you know, you can spend time on things that matter more, like, you know, spending time with your family as well. So
it's so true. I think that that's the number one benefit that everybody that I know talks about associated with this. They're like, I get 2 hours back in my day as an urban liver.
Yeah, it's really some things have been really, really good.
Good. Well, I'm glad that it's going well, and that you've got like such a great relationship with your whole team in order to help make all these different pieces work together into such a symbiotic relationship. So if we're going to back it up a little bit, and, you know, I know that you've got some kids at home, how did you describe what you do to your kids when they were 2 years old?
Yeah, so I mean, that's something that I definitely had to figure out. You know, one thing I've done quite a few times is to go to my kids' school, for instance, and to talk to the children there about computer vision and about the research that we do. And you definitely have to change your chip, right, and get to them. But I think we're very fortunate with that. You know, vision is something that's so intrinsic to us that everybody can understand it. So, you know, for a 2-year-old, very, very, very young person, the kind of thing that I would do is, you know, do something a bit like a game, right? So you would tell them something like, you know, go into that room and can you find your favorite teddy bear and bring it back, you know, and then, you know, they would probably run and find it very quickly and then, you know, bring it back. And then you would say, okay, now I'm going to blindfold you, or, you know, close your eyes and now find this other thing and, you know, and bring it back. And, you know, obviously they would very quickly realize that vision is so important to carry out many of the tasks that we do.
Sure.
You know, I'll give them a picture of a few people and say, find your mum in that picture, and, you know, is she happy, or is she a bit sleepy, or, you know, try to get them to reason about the information that's in images, and to see that it is something that comes so natural to us.
And
And
then you
then think, you
explain
know,
that
how
you're
could
trying
you
to
make,
get computers to understand the
yeah,
same thing.
how could you get a computer to do the same thing? Oh, you know, you put a camera. Oh yeah, but still, you know, the images, you still have to make sense of those. And these are the kind of things that we do. They're a little bit older, then it's easier. I remember going to my son's class when he must have been about 9 or 10. And I went to talk to them about visual effects for the film industry, and, you know, how you could synthesize all these images and use them in films and
And they
generate,
got
you
really
know,
excited about that.
and then they can really connect with that, right? And video games and things like this. So I think we're very fortunate in that it's a field that everybody can relate to.
Yeah. Do you remember when you first became really fascinated with computer vision?
Yeah, I do actually. It was just after I finished. I studied physics in Madrid. That was my undergraduate degree, and then I did like a master's on computation, let's say, or computer science type masters. And that summer, after I'd finished my masters, I went to a summer school where they were, and one of the presenters were people from a research group where they were working with robots, and they had a project in robotics where they had a robot that had ultrasound sensors, and it was, you know, moving around the environment, avoiding obstacles based on the information that it was gathering from the ultrasound sensors. And eventually, I actually, you know, I was so fascinated by this that you know, robotics and being able to get a robot to move around based on the information that it can see, that I then started my PhD exactly with that group, with that research group. And then the topic of my thesis was, instead of having the ultrasound sensors, to have 2 cameras that were looking at the world and trying to infer information about the world to guide the robot, which of
So
course tend to be
when was that? Because now, you know,
oh
perception has kind of overtaken the robotics industry and is seen as
yeah,
like the forward, the future of it, right?
yeah. So I started my PhD in 1991. So a very long time ago. A very, very long time ago, yes. And of course, you know, what we could do in those days was actually pretty limited. But in some ways, you know, I mean, many of the problems still remain, right? I mean, it's quite interesting that we have moved quite a lot in this field, but it's such a complex perception problem that we're trying to solve, that we, in some ways, we're only scratching the surface just now.
That's incredible that, you know, 20 years later, here we are. And, you know, it's still having the same types of issues you're solving for the same kinds of problems that you initially started to look at and solve for back.
Yeah.
Fascinating. So when did you decide to specifically focus on 3D reconstruction process from these videos and images?
So, I mean, the reason why I was always fascinated by 3D, gathering 3D information from images, was that, you know, many tasks can actually be solved just with 2D information. So, you know, imagine, for instance, taking images and recognizing whether objects are present or not in an image, or to try and find out, what are the different parts of an image, or, doing, for instance, recognizing whether someone is smiling, or finding where the faces are in a picture. So that many tasks can be done just in 2D. But for me, the more interesting tasks, the tasks in which maybe the computer needs to interact with the world, or think about a robot, for instance, where the robot has to interact with the world. Suppose that you want to build a robot that is going to take out all the clean stuff from the dishwasher, empty the dishwasher, and clear everything away. You need 3D information for that. And those are cognitively, those are very, very complex tasks, because they require not just recognition and being able to identify the objects, but also to be able to estimate their shape. How am I going to grasp the objects, and what's the actual interaction? Or think about maybe something more related to Synthesia, right? Suppose that you have a virtual assistant that's going to be helping you do your shopping for clothes, and in the future we'll probably be doing a lot of this online, and we will be able to try things on to the extent where we can really synthesize an image with ourselves wearing those clothes. We can move them around, we can see what we look like from one side or the other. We still can't do that. It's quite limited what we can do. For that, we really need to be able to synthesize those images. We need to have really good 3D models, and we really need to be able to model clothes. We need to be able to model the whole human body. And that's what's always really fascinated me. It's how from just images, how can we go to the third dimension? And how can we recover that third dimension that was lost when you project all the stuff on the images?
Very interesting. I mean, I think that my husband would totally agree on the complexity of unloading the dishwasher. But it's Jan LeCun and a couple of others have talked about how the way that AI really is going to come alive is when we're able to put vision and perception and everything else into robots, because then they can start to collect the same kinds of information that we do and develop real intelligence around it. And so that's what it kind of seems like to me is a big factor in this.
Yeah. It's really, the loop between perception and action. Perception, reasoning, action, that loop is really, as I said before, we haven't really, that's what will take us towards general AI. At the moment, we're good at solving very small sub problems and very small specific problems that have an input and an output, and solving very specific tasks. But if we want to be able to generalize more, then the perception, and in particular 3D perception, is going to be crucial. Yeah.
Interesting. So I'm a little far off from being able to buy a robot who can do my dishes for me. I'm excited for that day.
We have actually advanced surprisingly quickly in certain things. Maybe even just 3 or 4 years ago, there were things that we never imagined we'd be able to do today. So, perhaps we are moving in an exponential way, hopefully.
Agreed. It's what gets us really excited about all of the work that you are doing in Synthesia too, which is one of our portfolio companies. But before we get into Synthesia and your journey with them, tell me a little bit more about this recent publication that you've got, Frodo.
Yes, so this is one of our most recent paper. We've only just put it on archive a few days ago, and it will be presented at CVPR this year, which is the major conference in our field in computer vision. So this has been a really cool collaboration between my PhD student and myself, with Facebook Reality Labs, and with the University of Adelaide. It's quite an ambitious problem that we're trying to solve. So we take a bunch of images from, let's say, a room, so where there are some, chairs and tables, so different kinds of objects and of different object categories, a combination of chairs, tables, whatever. We take an image sequence, and then what we do is that we first of all we recognize and we localize those objects in the images. And then we build a 3D map where we reconstruct those objects. And the way that we reconstruct the objects is quite unique, because we've learned in advance maybe how the shape of chairs varies across a category, right? So we use machine learning, and we feed this algorithm many different chairs. So we can then learn, how the shape of chairs changes across a category.
Wow.
So it has a very, very nice representation for how shape changes across a specific category of objects. And then the idea is that we then, we take these images and we find out, which of those chairs corresponds to this particular image, right? So we represent the chairs in that embedding space that we've learned before. So the nice thing is that the output in the end, you feed it some images, and what you get at the end is a map of the room, where you have, the chairs and the tables in a particular place with their correct orientation and their correct shape.
Wow.
Which is,
so you literally make the room come to life.
It's going a bit beyond what maybe more traditional reconstruction algorithms do, which is to say, I'm going to reconstruct, a point cloud that represents or some surfaces that represent the scene. Here we reconstruct individual objects completely independently, and we kind of, we reconstruct them a bit like CAD models. This is the object. And,
very interesting. So a bunch of different CAD models that actually come to be a much more realistic envisioning of the room that those pictures are trying to represent.
Yeah. So the cool thing is that we go from, a bunch of images to a very nice representation that then, say a designer wants to come along and use this representation, right? They can then manipulate the objects, they can maybe, rotate them around, and they could potentially then render new images and say, well, if we moved your furniture around, this is what it would look like. So we're trying to go from images to 3D representations that are easy to edit, that are easy to understand by a robot, or to edit by someone who's going to be synthesizing new images, a content creator, for instance. So
very neat. I know, like, one of the industries that's really been affected by the pandemic at the moment is real estate, and not being able to show houses and apartments and everything like that. And so I could imagine for them being able to take the photos that they already have of a lot of these places and automatically represent them accurately in a virtual environment that people can then do their walkthroughs would be a game changer.
Yes, exactly. So yeah, this is the sort of direction. So if you can, distill the information that's in all of those images and represent the world in, at the level of object. So, here's one object, here's another object, this is its shape. And these are representations that can then be manipulated more easily.
Oh, very cool. So tell us a little bit more about Synthesia. When did it get founded? How did you guys get Synthesia off the ground?
So this was back in 2017. So we met through something called the Digital Catapult, which is, well, it's like a government organization that wanted to build a 4D capture studio in London. And somehow, the co-founders, that's where we met. We were involved in this process, and that was where we met. And then we started talking about our interest in creating content. So in helping content creators in the process of synthesizing video, for instance. And of course, our co-founders are, so Victor Riparbelli, he's the CEO of the company, and Stefan, he's the COO. Well, they came to this from a more entrepreneurial side, right? So seeing the kind of the technical side and how that could be exploited as a business. I obviously came to this from a very more, much more of a scientific side, same as Matthias Niesner, who's one of the other co-founders. So in some ways it was fantastic that we had the two sides were there. I think many other startups that I've seen have been created maybe just by scientists. And sometimes I think getting off the ground is a lot harder because we don't know anything about business. And so it's good to be able to have people who in the founding team who really have got this they know how to build a company, they know how to build a product, they know how to go out to investors and just relate this vision of what we really wanted to do. And I think that's been one of the keys, really, the fact that we had really good science, really good technology, and a fantastic business and entrepreneurship team that is just super passionate and obviously very knowledgeable about how to go about building a business around these products.
Definitely.
And then the other important moment was of course also our CTO John Stark, also joined pretty much right from the beginning, and he'd been working for the visual effects industry for many years. And so we just had the perfect team, the perfect
together it's the dream team.
Yeah.
We always like to think about that a lot for us because we specialize in looking at deep technical founders, but the marrying of the business and commercial side of things with the science and the technology is absolutely critical to success in so many ways. And so it's nice that you guys were able to find that right off the bat in a way that is really great for everyone involved.
I agree. I think it's this having that expertise and the fact that in the end everyone is driven by the same passion, no matter whether you're a scientist or you're a business person. In the end the passion is the same. It's our passion really is to create tools for content creators, to enable them to change their videos and to create something much more easily, and for them to be able to really exploit their creativity without the technical side being something difficult that they have to overcome. We can solve that part and they can then be completely creative.
Fantastic. And so, just to break it down for people who are listening, right, what Synthesia does is, your tagline is democratizing the video space, right? So content creation in video,
Yes.
which is really unique. And one of the things that I really like is the new product that you guys are launching, that create.synthesia.io product,
Yes.
where you can really just go in and type in a question or a statement, and it can automatically produce a video for you of somebody saying exactly your script. Are these AI presenters though, are they based on real people, or are their faces AI generated?
So the presenters that you'll see on the Create platform, they are real people.
Wow.
These are not synthetically created, so they're real people. But what we do is that we have, let's say, we capture a 3D model of those people, and then we can then synthesize a new video where the person is now saying whatever you type in there. Yeah. So it's doing text to video. So at this point you type in whatever you want this avatar to say, and then we synthesize a new video where the lips are now moving in a way that the person is actually saying what you want. And we're also working towards maybe even the body language, also, you know, to be able to edit that as well, and to be able to
Wow, very interesting. So that you really could, think of it as a stock video type platform where somebody can sign on as an individual content creator and generate a video that is exactly what they're looking for without ever having to film a single thing.
Exactly. And of course, you know what, right now we have a certain number of available avatars, but obviously the idea is to build more of these, maybe for, you know, customers to have like a premium product that we can build their own avatars as well. So, you know, I want these 3 or 4 presenters, and we can build some more avatars. But yes, the idea is to be able to, so creating or shooting a video is just extremely expensive. It's you know, the videos that we normally take with our laptops or with our phones, they're very low quality, and anything that you then want to use to maybe to promote your company, or anything that's been used as video stock afterwards, has to be shot in, you know, good conditions, and that's expensive. So our idea is, you know, if you just to shoot once, and then you can repurpose the video, and you can get that person to say completely different things to what the video was saying at the beginning. So you can adapt your advertising campaign to the new year, something different, a new product is being launched by the company, but you can still use the stock video that you had before. Yeah.
And is that the direction that you see the future of this whole industry going, is on, decentralized content creation, where people can use synthetic, you call them avatars, but they are people, right? Like they're real people, it sounds like.
Yeah.
To ask questions and to present things in the same way that people do now live.
Yeah, so there are, I think for me, there are many different directions in which this technology can go. I mean, obviously, one of them, you know, is, I mean, think about these AI assistants, right? So things like, you know, Alexa or Siri, and at the moment, they're just based on voice. And, you know, it would be very nice to be able to have, you know, instead to have an image of a person. And even, you know, for that video to not just to say something, but for to be able to express some emotion, to be able to you know, also the body language, as I said before, for that to be editable as well, you know, so that you can you can yeah. And the other idea, the other direction, of course, is for, you know, any other content creation. Like, you know, eventually something that we dream about is, you know, think about movies, you know, where you might be able to say, well, you know, you don't necessarily need to shoot everything the same way that that's already happening right now, but, you know, you can you can have much kind of higher levels of control over the way that you generate your video. You can say, you know, you can just maybe say roughly how you want the body to move. You can just have a little skeleton that says, you know, I want this motion to happen, or I want this emotion right now.
Wow.
And to be able to have a much higher level control over the creation of video than having to go and edit every single pixel, right? I mean,
yeah,
that
for
would be
sure.
the other end.
So many takes on something, like from my limited understanding of the video industry and videography, a lot of times there's multiple takes of every single scene until they can get it pieced together just right in the way that they wanted to. But if you could instead do it in one take and then alter it in all of the ways that you wanted to see, then yes. I can imagine that cuts down significantly on production time and cost.
Yeah. And for that to be as automated as possible, right? So that, you know, if you do have to go in and do some edits yourself, so those are, you know, super simple, maybe just, you know, a little slider that allows you to, for the person to smile more or less, or, you know, for you know, just having much higher level control, or as we said before, type in the text, and then that's already you have a new video synthesized with a new text. It's a major breakthrough, really. being able to go directly from text to video, because it does mean that, you know, you can, for companies, they have much easier access to be able to create their own videos.
Definitely.
This is something that we've now experienced, for instance, with the current situation, right? With the pandemic, with lockdowns in different countries. So no one can shoot video at the moment. Everything is closed, and so many companies have come to us and said, you know, we do want to create some new videos. Can we repurpose maybe footage that we had from before, and can we reuse it and create something new, but with the existing stock video? And that's great, of course.
Yeah, I'm sure that they love that ability to be able to monetize what was just all of the outtakes before, or that wasn't just perfect. Very interesting. You know, I think we would be remiss if we didn't mention the fact that there are a lot of people who are afraid of misuse over this kind of technology. You know, everything with deep fakes and whatnot. What, you know, what is your response to that? What is Synthesia doing in order to showcase the fact that, like, well, it is possible to do that. There are good ways to go about generating video that is really helpful for people.
Yeah. So we're doing a lot. We really are. You know, that we have a very strong ethics code, and
I love that you can see it right up on the website. You guys project it out there as transparently as possible for everyone.
Totally. The first thing that was, you know, one of the first things that we decided as a company was that, you know, we would always need consent from everyone, you know, from whoever is involved in the process. So either, well, mostly the person that we're going to the person that we're going to synthesize the video of and reenact, we need written consent, and we will always have written consent. We also, you know, we also have consent from, you know, the people that we have recorded, maybe for when we do video translation. So that's one of the other aspects of our company. So, you know, if you have a video, for instance, you shoot a campaign in one language and you want to then translate into multiple other languages, this is something that we do as well. And for that, we actually need to take a video of someone saying the same words in another language, right? So obviously, you know, we also have consent from those people because they're also lending their voice for the reenactment. So this is really, really important to us to, you know, never use it for any situation where both sides have actually given consent. But we are working towards, you know, creating, you know, maybe just around this industry, to create awareness around this, and to be able to, you know, think about standards. You know, how could we come up with standards where, you know, maybe every video has some sort of code or, you know, a stamp where, you know, all the, let's say, credentials about, you know, who were the actors involved in this, they've given consent, this is the software that was used to synthesize the images and to change the images. So to be able to really have a, you know, a unique kind of code that really tells us about the provenance of that video.
That's fantastic. That sounds really interesting, and like, you're probably going to garner a lot of support for that across the industry from all of the people like yourself who've been working so hard on this for all of the right reasons.
Yeah, and I think that, you know, in some ways, so this process has already happened for images, right? So the fact that images could be manipulated, and then, you know, people wouldn't know whether it's an image, the original image, or whether it's an image that's been manipulated or that's been synthesized. This is already something, this process is already, we've already gone through this. So it's important to know that, you know, that there's already a lot of there's already a lot of knowledge in this in this kind of industry about how to go about this, right? How to protect information so that we know the provenance.
For sure. Interesting. So I guess really quickly to wrap things up, but what kind of advice do you have for other professors who are looking to commercialize their academic work?
So I guess I'm going to go back to what I said before. Is really, choose your team really, really well. I think it's super important to obviously to have a passion and to to obviously to know exactly just what you want to develop and to have a passion for that. To have a dream, let's say. So as I said before, our dream was to say, well, we want to provide content creators with better tools, right? That's the kind of dream, and we know that we're good at it, and we know that we can do it. But then you have to surround yourself with a team that can touch on all the different types of expertise that are needed to build a company.
That's great advice. All right, last one. What would your career choice be if computers didn't exist?
I think for me that's quite an easy one, because I've always said this. I think I've always said that if I hadn't done computer vision, and I would have been a dancer. Actually, I love dancing, and I mean I'm not very good at it, but I every time I go and watch a show or I try to dance, so I just love it. I think it's a wonderful way of expressing what you feel about the music and the space, and I just really
That's
love
fantastic.
it.
I think my toddler would totally agree with you. She hasn't changed out of her ballerina outfit in 3 days, I think. But yeah, this has been a wonderful conversation. I really appreciate you making the time to talk with us about your research, about your journey through computer vision, and what it's like now to be the co-founder of such a fantastic growing company in the synthetic media space. So thank you so much. And look forward to talking to you again soon.